Okay folks, here's the next example. You got a car that you need to have lifted. The handle of the jack is 0.4 meters long, so that's how long your handle is. So if you think about here's your handle sticking out from the side, and that's 0.4 meters long. Now you have to turn the handle around the circle to lift the car. It takes a force of 50 newtons to turn it one complete revolution. So as you turn the handle around once, it's going to take a force of 50 newtons. That's going to raise a 1,000 kilogram car 15 centimeters. Calculate the efficiency. Now remember, efficiency is the work out divided by the work in. Work out is without any assistance. Work in is when you're using assistance. So first, let's find out how much work it's going to take to use our crank there. So if we want to find the work in, remember that's force times distance. We know it takes 50 newtons of force to lift it. But how much, what distance are we using, or what distance are we moving? It's not the height of the car. It's what distance are you moving to lift that, to move the handle. So what distance are you moving the handle through? As you turn the handle around, it's the shape of a circle. So what distance are you moving the handle? If you remember, distance of a circle around the outside edge of a circle as you start rotating around here, the distance is called circumference. And it shouldn't be anything new. So if we look here, distance that you're going to move the handle is 2 pi r. 2 pi times 0.4. And again, I could see where some people may decide to use 15 centimeters, but think about the machine you're using to help you. What distance are you moving that for the work in? Don't worry about the height of the car. How much work does it take to use your system? So you would end up moving the handle a circumference of 2.512 meters. Now the work in, 50. We know the distance that we just moved it. So it's going to take a little over 200 joules. Now to get your work out, excuse me, your work out is the 15 centimeters you're lifting the car. So you've got your car, you're going to raise it 15 centimeters. So force times distance, the car is being lifted vertically. So the force is mass times gravity times distance. Mass 1,000 kilograms, you're moving it against gravity, 9.8 meters, and you're moving for a distance of 15 centimeters, or 0.015 meters. So it would take 147 joules just to lift the car. So if you were strong enough to go out and lift the car on your own, it would only take 147 joules. But it takes 260 joules to turn the handle around to lift it. So we have what we expected. The work out is smaller than the work in. So your efficiency, let's get rid of this. So out divided by in, 73%. Example 6, a pulley system is estimated to be 90% efficient. An engine with a weight of 2,000 newtons is to be lifted at a height of 1 meter. And a force of 100 newtons is required to use the pulley system. And what distance is the pulley system used over? So you get an engine. This engine needs to be lifted 1 meter. To use a pulley system, it's going to take you 100 newtons. So we've already got, right now, the work in. So 100 newtons of force is required. The work out, well, we can figure that. Work out, you're lifting this engine vertically. So it's force times distance. Well, we know the force required to to lift it straight up is 2,000 newtons. And it's going to lift it over 1 meter. So it's going to take 2,000 joules. If we look here, to work out, 2,000 joules as we had expected. Now if we think back to our efficiency formula, efficiency is your work out divided by the work in. This number has to be bigger. This one should be smaller. Well, we know our efficiency. .9, 90%. The work out is 2,000. So the work in, we know that. Cross multiply and we'll figure out the work in. Now the work in, cross multiplying, we get 222 joules. Now we know the force, we had just set it up here. The force for the work in was 100 newtons. So fill in that number. And now we have to solve for distance. So divide by 100. And it's 22 meters. So you're using the pulley system. And I'll just pop down here to the next example because I have a picture. But in a pulley system, you're going to move 22 meters of rope to lift that engine block 1 meter. So that's the distance that's referring to there. And what you should have noticed by now is that the distance of the system is not the same as the distance that the object's being moved. So here the engine was being moved 1 meter, but what distance did you have to move the pulley system? So there are two totally different distances involved here. It's important not to confuse them. Okay, last example. Fishing boats are often hauled on shore at high tide. This gives the owner about 12 hours which to apply the copper paint that protects the wood from damage. The copper paint would here be applying, and it's going to prevent it from building up sludge and another slime on the bottom. It is estimated that an applied force of 4,200 newtons is needed to haul a boat 3 meters away from the water's edge. To do this, a haul system is used by one person with an applied force of 410 newtons, hauling 42 meters of rope. So I want you to calculate the work out. Use this to find the work in, and use both parts A and B to find the efficiency. And I'll be reviewing this question in class on Monday, and I expect you to have it done. Thank you, and remember you also have to hand in your homework set of questions.